Hello everyone. Today I'll be presenting our project on automated summarization of Reddit threads using NLP. I'm Anil, working with Sana and Param on this project. Our group name is the Transformers. Our goal with this project was to explore how effectively small language models can perform extractive summarization on Reddit posts, which are often lengthy, informal, and challenging to summarize automatically. Reddit contains valuable information, but posts are often long and time-consuming to read. While most summarization research focuses on large models for extractive summarization, we took a different approach. We decided to investigate whether lightweight models running locally could perform effective extractive summarization. We selected key sentences rather than generating new text. This question in particular is relevant with the growing interest in on-device AI, like Apple's recent summarization features in iOS and various other Android OEMs that have some kind of on-device AI. Current approaches typically use large transformer models like BARD and T5 for extractive summarization. While effective, these models are resource intensive, requiring powerful GPUs and significant memory. Our insight was to explore extractive summarization using small local LLMs by using Ullama, evaluating different models on the WebIS TLDR17 dataset. The WebIS TLDR17 dataset contains Reddit posts with human-written, too long, didn't read kind of summaries. Our analysis showed the average post contains about 296 words across 14 sentences, while the human summaries average just 30 words in 1 to 2 sentences. For our experiment, we used several lightweight models with the help of Llama, like Gamma with 2 billion parameters, Gamma 3 with 1 billion parameters, Gamma 3 with 4 billion, and finally, DeepSeek's R1 model with 1.5 billion parameters, all of which are capable of running on consumer hardware like my MacBook M1. We explored two prompting strategies, zero shot and few shot. With zero shot, we simply instructed the model to extract important sentences that capture the main points. But with few shot prompting, we provided examples of posts and their extractive summaries to help guide the model. For evaluation, we initially used rogue scores, but we later realized they didn't quite capture performance in the way we were anticipating. It was probably due to the mismatch between extractive and extractive summaries. BERT score, however, proved more effective, as it measures semantic similarity rather than just lexical overlap. Our results reveal clear patterns across different models and prompting strategies. Few-shot prompting consistently improved performance across all models tested. Gamma with 2 billion parameters increased from 0.65 to 0.79, while DeepSeek saw a dramatic improvement from 0.5 to 0.8 with few-shot prompting. Gamma 3 with both 1 billion and 4 billion parameters showed the strongest overall performance, with Gamma 3 with 4 billion parameters achieving our highest BERT score of 0.7 with few-shot prompting. Interestingly, even the zero-shot versions of these models perform exceptionally well at 0.81 and 0.84 respectively. This suggests that newer model architectures have better inherent summarization capabilities, regardless of the count of the parameters. When models succeeded, they captured key ideas and maintained coherence, as seen in our gaming PC example as well. However, they sometimes produce empty predictions, particularly in the case of zero-shot settings. For example, with DeepSeek with 1.5 billion parameters, zero-shot failed to produce summaries for 55% of the posts. This variation across models highlights the importance of testing different prompting strategies rather than assuming one approach works universally. Our findings demonstrate that even small models can produce reasonable extractive summaries with the right prompting. Few-shot prompting significantly improved performance across all models, with the best results coming from DeepSeek with 1.5 billion parameters few-shot and Gamma 3 with 4 billion parameters few-shot. A key insight is that for extractive summarization with small models, quality prompts matter more than model size. This suggests that practical applications for on-device summarization are already feasible. Looking forward, we see several directions for future work, expanding to other domains like news or product reviews, exploring hybrid methods that combine extractive and abstractive techniques, refining our prompting strategies even further, and potentially fine-tuning the models specifically for this task. Thank you everyone for your attention.